Here at Claremont, New Hampshire, my friend Tim Donovan's hangar, to make a video of my Carbon Dragon. I call it the Magic Dragon because it differs quite a bit from their original Carbon Dragon plans, and I'd like to go over, for those of you who are prospective builders, some of the changes involved in building this aircraft, and so you have a better idea of what it looks like. We'll proceed from the end of the wingtip in, and let's see, there's the fuselage of the wing. This glider here has got a wingspan slightly over 45 feet, which is over a foot longer than the original prototype. And let's see here, excuse my camera work. We'll go and take a look at the wingtip first, and you'll see the changes that I've made to the wingtip. The wingtip is more aerodynamically streamlined, and the mass weight balances are integrated into the wingtip design so that they are streamlined behind this portion right here, which is curved and made out of carbon. And you'll see that it allows for a larger surface, a little bit extended wing, but also you'll see that the weight balances, the flow over the airflow is not as disturbed as it would be in the prototype. The undersurface is also made a more gentle curve. This is a large fillet here. It simulates other sailplanes that have end pieces that I thought maybe would handle the airflow a little bit better. It's a little bit lower in profile than the prototype, but it's quite strong because it has interior and exterior carbon. You will note that there is a little tiny metal clip right here. This is what hits the ground when the wingtip sits down. That's what hits the ground. Okay. The wings are approximately, I would say, 5.5 to 6 inches wider on each end than the prototype. And we're going to go in and take a look at. Now, it's important to note that the major difference between this glider and the prototype is that all the exterior surfaces on this glider, including the leading edge, are molded graphite. And if you can see, if you look down the leading edge here, you will see that it provides for a very smooth, shiny surface. Now, the shininess is because of the paint. It's a Superflight system paint, a two-part paint. I'll get into that later. But the important thing is to note is that there's no deflection like you get in real plywood. Plywood humidity will cause deformation in this critical leading edge. That really is where the performance, a lot of the performance comes, and a lot of the laminar flow is held if the leading edge is true. And this one here is graphite, and it's a long time thing to try to accomplish that, but it seems to be working very well, and also it significantly enhances the strength of the glider. We have the canopy off, and the wires you see are the radios being charged. The radios are hooked to my harnesses. I have an aircraft radio. When you're flying in amongst other aircraft, you want to have capability of speaking to them, which is this one. It's a very small Yaesu aircraft radio. That's hooked to that harness. And the other one is my hang gliding vario. It's a 2-meter band radio that the hang glider pilots in local area use, and when I'm winch towing at Morningside, which is our local hang glider park, I have to have that radio in force. It has a long antenna that extends all the way back to the tail of the fuselage, and we'll go over some other things here. This headrest here is a little adaptation. It is Velcroed on, and I'll take it off so you can see the main wing bolts. But the headrest is Velcroed on and has Velcro strips on the back that connect it so it will be easily taken on and off during assembly and disassembly of the disassembly of the glider. The main wing fittings are made out of titanium. They're longer and have more bolts than the prototype. The main bolts are 3/8 inch bolts as opposed to the prototype calls for 5/16. And also the other fittings that connect the fuselage to the wings are also made out of titanium. This is the spoiler lever. It works just as per plans. I covered it with both sides with carbon, so it's a little bit stiffer, and it works pretty well. There is the spoiler up. It also has a middle range. It's pretty easy to actuate. You just pull it out a little bit, and it holds itself in these notches. That's the middle range. Now that's what you usually mostly use when landing approach. Very rarely do you use full spoiler. It comes down really quick when you use full spoiler. The seat here is a sling seat. I made a one to work with, a white one, and then when the glider was all finished, I made a more decorative green one that matches the color of the wingtips. The other thing to note here is my parachute actuation handle. That goes to the ballistic chute, which I'll show you. It's right in the back side of the spoiler. It's in that cavity right behind the spoiler, and I'll show you that in just a minute. Other things to note about the fuselage, and we'll just pan gently, slowly around the fuselage so you can see things. They'll help you get an idea of how to make them according to plans. This is the flap control lever. You'll notice that it is spring-loaded, and because of the design there, it's made out of fiberglass. This is the release. This is my ball graphics comp with a hood over it to keep the sun from coming in and obscuring the screen. This here is my GPS. It's mounted and connected to the graphics comp, which gives you a moving map display. There's the release mechanism right there. Mine is a little bit different, much simpler here. You don't really need to have the marine pulley type thing if you don't plan on adjusting your seat in flight that much. This one can be adjusted, but the reality of it is it's usually a pretty standard. You leave the adjustment once you get it set properly. There's the foot pedals. And let's see, we'll go to the other side here in just a minute. Okay, for this side. You'll note here that the control, there's the control of the elevator and aileron control tube right there, connects to this, the stick right here, side stick. You'll note that it does protrude out from the top of the side here. That's not really somewhat obscure on the plans, but you cover it with you make a small cover and it works out just fine. We'll go over and now we're on the other side of the aircraft, and I want to show you this the stick control lever, side stick. It's a right stick. Very nice and comfortable. It's very ergonomically designed. Your elbow just forearm rests right on here, and the stick is nice right there. But you'll notice the tube runs through, and it comes right there. And you can see how it connects to. Let's see if you can see that. Working the side stick here. Get this right there. That's a little bit better picture of it. I'll get in there and show you the balance of it as best I can. Let's see. I'm going to allow this thing to run while I kind of stick it in there and give you an idea what it looks like. Perhaps you can see the side stick mechanism working here. As I work the stick, you'll be able to see it working. Oops, sorry, I'm tilting a little bit there. Okay, I'll look down, way down low. Oops. Light here. Over to the side, that's the rudder control pulley there. There's the other rudder control pulley right there. This is the flaperon control wire right here. Give you an idea, those straps surrounding the main tube there are holding the parachute on. This right here is the parachute actuation wire, and this right here is the cable that goes back to the rear for the antenna of my 2-meter band radio. Okay, another look then at the side, how that goes. There's a seat belt. side stick, front forward bow, flapper on control lever. Now you'll note on each side the canopy is held in place by two little brackets. They're slider brackets. They push forward here. I'll show you how those work a little bit better in next when I get to it. But also note the style of the instrument bracket. It comes down to a Y. Let's see. I guess maybe we'll see it best this way. And then you can see how it was designed so that the GPS would sit right on it, with the top part of the GPS, the antenna part, facing straight up. Now, the front part of the bracket there connects right to the static and pitot base, which supports the whole thing, and the static and pitot base is connected right through the Lexan canopy. Okay, I think that's pretty good for the front part of the fuselage. We'll go back and take a look at the parachute layout. Okay, we're looking at the back of the rear of the spoiler here. Here's the main fuselage here. And I want to show you the parachute because that's an important thing that was difficult to engineer to get it into the small compartment. This is a BRS parachute. I had to make several alterations to the package to get it to fit in this compartment. You'll see it's fairly confined here, but the compartment is also defined by the top of the wing and defined in the bottom by the main structural tube here. So I had to rebuild the pack, resew the pack to have sort of a triangulated shape so it would fit in. It is attached to the tube here, and it's supported on the underside by styrofoam flanges that hold it so it doesn't collapse on its side too much. And the main harness for the parachute, the thing that grabs a hold of the aircraft, is wrapped around the main tube at the front and also connects to the side fittings on the harness fittings on the front. You're seeing right here the rocket, which is connected here to the parachute, and it's also mounted on the side of the. It's kind of difficult to see, but I had to make a bracket to fit on the side of through the side of the tube here it also grabs a hold of the main side longeron of the main tube. Some detail here showing the drag spar connections here. These are titanium fittings as well. And here, drag spar fittings. This is the drag spar connection. And the drag spar is this structure that comes up here that connects the main spar to the aft portion. It gives a triangulated support structure that's very important to maintain the structural loads at high speed, or at any speed actually. It's important to note that the drag spar on this glider was lofted, which means that it's not straight from here to here. It carries a curve that actually supports, that follows the curve of the wing down. It's called lofting. But also of note is there's some other features that I tried to incorporate from high-tech sailplanes. This is a very high-tech little sailplane. It has a lot of its own interesting features that Moffett and Culver incorporated in it. But what I could add was all of the parts being molded graphite. You're allowed to use complex curves. Now, if you look at the trailing edge here of the gap cover of the aileron gap cover, you'll see that it is a curved plate. It was designed to be curved. It curves down like this, and that's so that the airflow is forced to reattach on the trailing surface. That's very important, and it makes a much less draggy transition between one surface, the leading part of the wing, and the aileron part. When you're using carbon, it maintains its shape under humidity and temperature variation, so you can have a much more carefully defined gaps than perhaps if you use plywood. It takes a lot longer to build, but it really I'm very pleased with the way it's come out so far.